Okay, well, we have a similar situation here, but different things are going to be happening that we've done recently anyway. One way of kind of approaching this is to set up a table to see what's going on. We've got Henry, who's kidnapping bunnies. The farm had 8,000 bunnies, and he's going back daily, taking half the bunnies. Okay, let's not get into the logistics behind that, but if we think about what's going on, if we use n and t of n, because that's what we've kind of gotten used to doing, after 0 days have gone by, 8,000 bunnies exist. Okay, and after 1 day, half of them are gone, so there's only 4,000 left. After 2 days, half of these are gone, not the other half. Don't know why. It was big enough to take 4,000 the first time. Why not take this? But anyway, it gets down to 2,000. Half of that is 1,000, and so on. So after 3 days, we can look at our table. There's only 1,000 left. Okay. If we write an equation for the diabolical plan, we're looking at basically what's going on here. We have an initial value, how many days had gone by, and no days had gone by, we're at 8,000. And it's cut in half each time. So hopefully we can see that 8,000 is our initial value, and we're going to half the bunnies each time. This is a geometric sequence. Okay, it's multiplying each time, and we're multiplying by half. Even though we're trying to convince ourselves that we're dividing by 2, it's better to multiply by 1/2 because we have an equation there. At some point, Henry's going to be stuck with an odd number of bunnies. On which day will this occur? And we can continue. 4, we're left with 500. 5, we're at 250. 6, we're at 125, and I keep cutting them in half. And speaking of cutting them in half, it could get awkward when he's trying to get exactly half of this, because then we'd be cutting a certain number of bunnies. So an odd number of bunnies, on which day will this occur? It occurs on the 6th day. Okay. Theoretically, after how many days would Henry have to kidnap all of the bunnies? Again, theoretically, in bold there. All of the bunnies, well, you keep going with this, and you're going to be dividing bunnies into chunks and into smaller bits and pieces. And one way of doing that, and I know I sound very distant, I'm coming back now, but one way of doing that would be to use our calculator here. And I've got the 8,000. And I'm multiplying by 1/2, and I'm hitting enter. If I multiply that by 1/2, and then again and again and again, that brings us to our, this would be our 7th day. And I'm just going to rattle through these kind of quickly. 8, 9, 10, 11, 12, 13. Uh-oh. All the bunnies. Well, I should go back. That took me 13 to get to that. And then 14, I'm down below half of a bunny. So theoretically, when will they all be kidnapped? Well, if I keep going, we said this was 13 and this was 14. When is that number? Now, what does that mean? That's a scientific notation for a very small number. It's 3.7259 times 10 to the negative 6 power, which means move this decimal point over 6 places. This way. So it's 0.00, 5 zeros and then a 3. I keep going. I'm basically getting smaller and smaller, and I will get infinitely small, but I will never actually get to 0, not by just cutting something in half. So the answer to this is never. And you can argue how many days will you have kidnapped all the bunnies? Well, even at that one point we had 0.97, which was most of a bunny. But after that, if you got half a bunny, it's not going to be doing so well. So arguably 13 to 14 days, you can make an argument one way or the other. There's a difference here because we're never going to, since we're cutting numbers in half, there's always going to be a number left to cut in half. It'll be very small, but smaller, smaller, smaller. You can never get to 0 by cutting something in half, because you'll always have half of it left. However, you can say that the difference between never running out of bunny pieces anyway, and never having or running out of live bunnies, that's basically the difference there. And however much you can fit that on one line, do your best.